distance we are given 3 points, 1 negative 1 over 2 positive I times root 3 over 2 and negative 1 over 2 negative I times root 3 over 2. We are expected to show that they form the vertices of an equilateral triangle. Now if you were to take an equilateral triangle, all of the sides are equal. Have that in mind. Now if I were to represent these points, now 1 is the real part, okay? So 1 is going to be over here. So this is going to be the point 1. Now the next point is negative 1 over 2. So negative 1 over 2 starts over here, because if this is 1, if I were to take this as 1, negative 1 over 2 is 0.5. So that's going to be over here, negative 1 over 2. But the component is positive I root 3 by 2. So that representation would be somewhere over here, because root 3 is 1.732 and that has to be divided by 2. So that would give you approximately 0.8. Okay, so if I were to take this point as 1, 0.8 would be somewhere over here. So this would be the point. Okay, so if I were to connect this point, the point would be something like this. So my 1 would be over here. This is the imaginary part 1, imaginary axis. So in fact I have to mention it as I. The coefficient is 1, so I'm just placing it in this fashion. So this point would be negative 1 over 2 positive I times root 3 over 2. That would be the point there, root 3 divided by 2. Now simultaneously we need to have the point for the next part, because this is negative 1 over 2 negative I root 3 over 2. So that would occur on the other side of the axis. So that would be this point. So I need to connect these 2 points and make the representation. So this is negative 1 over 2 negative I times root 3 over 2. So if I could show that this distance is same as this distance, which in turn is same as this distance, then my result is complete. So what I'm going to do, I'm going to take this point as Z1 and this point as Z2 and this point as Z3. So first I would find out the distance between Z1 minus Z2. So that is going to be equal to modulus of Z1 is 1 minus Z2 is negative 1 over 2 positive I times root 3 over 2. Okay, so that is rewritten as 1. Negative negative is positive, it's going to be 1 over 2 there, and negative times positive is going to be negative I root 3 over 2. Now this is going to be equal to 1 added with 1 over 2 would give me 3 over 2 negative I times root 3 over 2. If I were to take the modulus, that's going to be root of 3 over 2 squared positive root of 3 over 2 squared. This is going to be root of 9 divided by 4. Root 3 squared will give me 3. 2 squared will give me 4. So this is going to be root of 12 divided by 4, which is going to be equal to root of 3. This is for the first Z1 minus Z2. Next I want to find Z2 minus Z3. Okay, this is the first step, step 1, and this is step 2. So okay, now we find Z2 minus Z3. So that's going to be equal to, my Z2 is negative 1 over 2 positive I times root 3 over 2, and that has to be subtracted with Z3 and obtain the distance. So Z3 is negative 1 over 2 negative I times root 3 over 2, which is rewritten as negative 1 over 2 negative negative positive. So positive 1 over 2 comes there, positive I times, this is root of 3 over 2 negative negative positive root of 3 over 2. So this is what we get. Now clearly negative positive gets cancelled. This is going to be 2 root 3 divided by 2 with the I there, and we need to take the modulus of that. So 2 gets cancelled. So you got modulus of I times root 3. You were to do the modulus, you'd get root of 3 squared, which is equal to root of square, and the square root gets cancelled, giving me root 3. Now the final part, I've obtained z1 minus z2, z2 minus z3. Now I need to find z3 minus z1. So I would just take z1 minus z2, okay, or z1 minus z3. It doesn't matter, okay, because we are only finding the distance. So this is going to be modulus of z1 is 1, negative z3 is negative 1 over 2, negative I times root 3 over 2, which is equal to 1. Negative negative positive is going to be 1 over 2 there, and negative negative will give me positive I times root 3 over 2. So this is going to be modulus of 3 over 2 positive I times root 3 over 2. If you were to take the modulus, it's going to be root of 3 over 2 squared positive root of 3 divided by 2 the whole square. This is exactly the same thing that we have got there, right? So this is going to be equal to root 3. Now this implies clearly, so you have to make the conclusion, okay, we have got a root 3 here, and a root 3 here. This implies the vertices, the points, you can clearly say they form an equilateral triangle. So you can make the conclusion. Okay, so that completes the solution to this question.